Hi there and welcome to this video for Senior Physics on Electromagnetism and Electricity. This is our final video where we're going to look at capacitor smoothing. Now, as we saw earlier in our AC rectification, we produced a set of curves which you can see in the diagram opposite. In this case, the negative portion of the AC curve has been flipped, so it now matches the other AC positive components and are all in that positive area of the graph. So that's great, but the trouble is we don't want this power surge. Now you'll notice that the voltage starts from 0, goes up to a maximum, drops down to 0, goes up to a maximum, drops down to 0, goes up to a maximum. This is like going up to the lights and switching them on and off and on and off and on and off. It's not good for the circuit. So somehow we need to convert this graph into a nice horizontal line. So energy needs to be constant. We need to get this constant flow of energy. Remember, voltage is joules per coulomb. Now capacitors help us smooth out these humps so that we get this nice horizontal line, and this is the principle behind capacitor smoothing. Now how does it do this? Well, you can see in the diagram here I've got a circuit where I've basically got a diode bridge, our bridge rectifier, and this is going to flow from a AC voltage. It's going to go through a resistor, RL, and then we're going to put a capacitor, and that's shown in the green circle. Now what's going to happen is, as the current is flowing, the capacitor will begin to charge up. So as the AC is reaching its maximum, we're going to get the capacitor, which is going to become fully charged. This means that there's going to be a lot of that negative charge on one plate of the capacitor. When the peak of the AC begins to drop down, the pushing the charge onto that plate diminishes. As it diminishes, this gives the opportunity for the capacitor to discharge. So it's going to be discharging as the AC is dropping down to 0. This delivers a certain amount of energy to our output voltage. So what we're getting is this delivery system from the capacitor, which is filling in those gaps that you can see up above. So if you look at the following diagram, you can see what I'm trying to explain here. We've got our peaks, so what happens is our capacitor will deliver energy where you've got the blue triangles. Now what that will mean is that we will get a RMS value which is going to be less than the peak value, simply because that energy which is being generated is not enough to reach that peak voltage. So we've used up some of that energy to fill in those missing gaps. This can be calculated for DC using the VRMS algorithm, basically that the voltage in from AC divided by √2. So we can add either better smoothing, and we can also check out how we could also limit the amount of voltage by using a Zener diode, and there was more on that in the diode sections of our videos. The Zener diode means that we can actually set our voltage at a specific constant, like 6.8 volts, and we will not get any more or less than 6.8 volts, which is going to be generated. So the capacitor smoothing allows us to fill in the energy gaps between those humps so that we get a constant supply of voltage, which is good for the appliance. So what the capacitor will continually do is it will continually charge and discharge as the voltmeter, as the AC current is beginning to drop, and then it will charge up as it's beginning to rise. So we get this continuous process. By being able to use that timing circuit that we talked about with respect to capacitors, we can always make sure that we're delivering the right amount of energy back to our appliance. Okay, so to recap or summarize what we've looked at over the last 2 units, we've got AC going to DC. We've used a diode for rectification, and this raises the negative portion of the AC curve into a positive. And we've now used a capacitor to smooth out or fill in the gaps from each of the peaks. And as a result, we will produce a horizontal straight line. Okay, well that concludes everything that we've done with respect to electromagnetism and electricity. I hope you found the course useful. Do try and rate it, and if you feel necessary, write a review. And I look forward to you meeting me again, and check out some of my other videos and my other courses which we've done in physics so far. So thank you for joining me, and I look forward to seeing you again.